Hi folks, happy Tuesday. Today's target is to be able to calculate the gravitational force, weight, and the normal force. This sounds like a really complicated topic, but actually it's really not quite that bad, and I think ultimately you're going to be very relieved by today's lesson, especially after the one that you received for Monday. So first things first, gravitational force. We learned how to calculate that yesterday. The gravitational force is simply equal to the gravitational constant times the mass of one object, usually a planet, times the mass of a second object, sometimes a person, but also sometimes a planet, divided by the radius in between those two objects squared. So that's how you calculate the gravitational force. It's just plugging the numbers into that handy-dandy equation. So what's the difference between the gravitational force and weight? There isn't one. Actually, when we calculated the gravitational force yesterday for the 65 kilogram man on Mars, we actually also calculated his weight. And there's a lot of great ways we can fact check that. But essentially, an easy way to calculate weight is to simply use this equation. Weight is equal to the mass of an object times the acceleration due to gravity. And you'll recognize that this equation is actually very similar to Newton's second law, F equals ma. Weight is just a force. Mass is mass, and the acceleration due to gravity is just a type of acceleration. They're the exact same equation, and we can use them to find the gravitational force or weight. Cool. So then why do we have this equation? Well, because we don't always know what the acceleration due to gravity is on a planet, right? Especially if it's a new planet like Mars, we don't have g for that planet. We have to first use Newton's fourth law before we can use W equals m times g. Okay, so if the gravitational force and weight are the exact same thing, what's the normal force? The gravitational force, or your weight, literally, your weight in pounds is a force. It's how much force you are exerting on the Earth. Well, we know that Newton's third law says for every action there's an equal and opposite reaction. So if gravity is pushing you on the Earth, and you don't just go straight through the Earth, because that's what gravity should do, right? It accelerates objects, so why is it that you don't just fall through the Earth? Well, because there's an opposite force that is counteracting your weight, the normal force. Let me show you a picture. Okay, here is Earth. And you guys may have heard the story of Superman. Here is Superman. Big billowing cape. Nice. Superman has a mass. Actually, he technically, there we go. Superman, he steps on a scale on Earth, and the scale tells him that he weighs about 300 pounds. And Superman is really interested in physics, and Superman wants to know what his weight is in newtons. So how does he do that? Well, first things first, we have to get rid of pounds. LBS stands for pounds, by the way. We need to get rid of pounds. We need to get that into kilograms, because kilograms is a scientific unit and pounds is what Americans use. Since Superman's living in America, he measures his weight in pounds, but needs to convert that to kilogram. Okay, pretty easy to do. All we need to do is take 300 pounds and convert it into kilograms. I will tell you, if you ever have this on a test, I will tell you it then. There are 2.2 pounds in 1 kilogram. Okay, so we need to take 300 pounds, multiply it by 1 kilogram, divided by 2.2 pounds. Our pounds cancel out. 300 divided by 2.2 is 136.4 kilograms. Cool. Okay, so now we actually know his mass, and we've got the right units. We've got those kilograms that we like. We also know that the acceleration due to gravity is just 9.81. So in order for Superman to figure out his weight, we just take his mass, 136.4 kilograms, times the acceleration due to gravity, which is 9.81 meters per second squared. And that will give us his weight. So we punch our numbers into a calculator. There we go. And Superman has a total a total weight of 137.7 newtons. Cool. All right. So we just calculated both his weight and also the gravitational force that the Earth is exerting on Superman in the downward direction. 137.7 newtons. Boom. Okay, so where is this normal force? Well, the normal force is just acting in the equal and opposite direction. For every action, there's an equal and opposite reaction. So the Earth, as weird as this sounds, is actually pushing Superman up with 1,337.7 newtons of force, because if it wasn't, Superman would just fall through the ground. After all, forces cause things to change their acceleration. So if Superman has an acceleration of 0, that means that the net force on Superman is 0. So any force pushing him down must be counteracted by a normal force pushing him up in an equal and opposite direction. Your assignment today is going to be to calculate your weight and normal force in today's exit slip. Good luck. I'll talk to you more tomorrow. Bye.